Hello everyone. Today's lesson we're going to still simplify radicals, but the radicals we're looking at have higher roots. So rather than just taking a square root, we're going to look at a cube root, fourth root, fifth root, even up to the seventh root. And in order to do so, we need to understand our powers, our numbers. Just as we made a list of the first 20 perfect squares, we're going to make lists for perfect cubes, the fourth powers up to the seventh powers. The nice thing about it, though, is because as we raise something to the seventh power, our numbers get larger a lot quicker. So the lists aren't nearly as long as the list for the perfect squares. So let's start right now, and please make sure you write these down and have them available. Let's go ahead and write out some perfect cubes. So what we're going to do here is just simply cube 1. So 1 raised to the third power is just 1. 2 cubed means 2 times 2 times 2, so that's 8. 3 cubed is what? Should be 27. 4 cubed is 64. We're not going to go too much further. 5 cubed is 125. 6 cubed is 216. And that's usually the furthest I go, but I am going to go with 7 and 8. So 7 cubed, 7 times 7 times 7 is actually 343. And then 8 cubed is 512. So we just have 8 numbers here versus the 20 numbers that we were looking at for the list of perfect squares. After this, we don't really have a special name, but next let's go ahead and call them the fourth powers. Again, our list is going to be even smaller. So remember, 1 raised to any power is just going to be 1. So 1 to the fourth is 1. 2 to the fourth means 2 times 2 times 2 times 2. That's actually 16. 3 cubed, I'm sorry, 3 to the fourth rather, is 81. 4 to the fourth is 256. And we'll just go to the 5 to the fourth power is going to be 625. So we could see how much shorter our list is getting right away. Let's do the fifth power. Again, 1 to the fifth is 1. 2 to the fifth, all we really have to do is go back to the previous one. So it's just 16, because that's 2 to the fourth, multiplied by another 2. So 2 to the fifth is 32. 3 to the fifth is 243. And we'll just do 4 to the fifth is actually 1024. Next is sixth powers. Again, 1 to the sixth is 1. 2 to the sixth, if we took 32 and then multiply that by 2, we get 64. 3 to the sixth is 729. We'll just do one more. 4 to the sixth is actually 4096. And then our last one we'll take a look at here is seventh powers. We'll just do the first 3. Again, 1 to the seventh is 1. 2 to the seventh just means we're going to take that 64 and multiply that by 2, so 128. We'll do 3 to the seventh. It's actually 2187. Now all these numbers that are in the thousands, you don't have to sit here and memorize them. Just have this as a nice reference list. So there's a worksheet I'm going to give you guys. You're going to have the evens to do, so I'm picking out some of the odds. So we'll call this the higher roots worksheet. Okay, so let's just take a look at number 1. Now, this number right here, the 3, that's called the index. That's indicating which list we have to go to help us factor this, because it's telling us what root we're taking. So when we don't see a number, it's the square root. When we see a different number up here, that's telling us which list to go through. So when we're looking at the cubed root, we want to go back to our list of perfect cubes. Now the variables are going to change too. We'll take a look at those here in a moment. But right now we're just looking at the cubed root of 625. So let's go back to our list of perfect cubes. As I'm going through this, because it ends in a 5, guess what? I'm going to try the 125. So I'm actually going to factor this. Don't forget to keep writing out that cube, that 3 for the index. So this is going to become the cubed root. And it's actually 125 times 5. Yes, I will let you guys, you can absolutely use calculators on this. So if you divide 625 by 125, we get 125 times 5. Now I'm going to circle this because I'm going to now take the cubed root of it. The cubed root of 125 is 5. And then I still have the cubed root of 5 left over. So make sure, again, you have that index there, because if not, you're writing 5 times the square root of 5, and that's a completely different answer. Let's go next to number 7. Here we have a negative 4 times the 4th root of 96. So as I go back to my reference list here, I'm looking at the 4th powers, and I'm just going to look at this list. Now, if it's 96, 81 definitely doesn't go into 96 evenly, so my only other choice is 16. So on your calculator, go ahead and divide 96 by 16. We're still going to write the negative 4 out in front, still the 4th root, but 96 is 16 times 6. So now I'm going to circle the 16. Now remember, I'm taking the 4th root of 16, not the square root. So I still have the negative 4 out in front. The 4th root of 16 is what, guys? It's 2. Then I have the 4th root of 6 left over. So here I'm going to get a negative 8 times the 4th root of 6. Let's jump down to number 17 next. 17 is the 5th root of 224 times p to the 5th. So now when we look at variables, we want to make sure that this exponent can divide by the root that's out here. And in this case, it can't. But let's go to our list of 5th powers. So we're looking at a 224. So 243 is too high. So 32 has to go into 224. So if you go ahead and divide 224 by 32, we'll get the 5th root. Should actually come up to 32 times 7. And I'm going to leave p to the 5th alone because 5 divides by the 5 that's out in front. So I'm going to circle the 32, and I'm going to circle p to the 5th. So the 5th root of 32, go back to your list. The 32 is the second number, so that's 2 to the 5th is 32. So the 5th root of 32 would be 2. Now p to the 5th, when I divide this 5 by this 5, it just comes out as a p. So I have 2p times what's left over is the 5th root of 7. Let's take a look next at number 19. We have negative 3 times the 7th root of 896 times r. All right, so let's go back to our list of 7th powers. We don't have too many numbers. 128 has to be it. So on your calculator, divide 896 by 128. So we still have negative 3 times the 7th root. 896 divided by 128 is 7. So we get 128 times 7. And I only just have r to the first. So I have no choice just to write it that way. So the only part I'm circling is the 128. So I still have the negative 3 out in front. Let's go back. 2 to the 7th is 128. So the 7th root of 128 is 2. And then I have the 7th root of 7r left over. So this finally becomes negative 6 times the 7th root of 7r. All right, just a few more to try. Let's go to number 21 next. All right, this is negative 2 times the cubed root of negative 48 times v to the 7th. So one thing I want to point out here, notice we have a negative number underneath the root. So we can take the cubed root of a negative number. We cannot take the square root. So as long as the root is odd, we'll write this out. We can take an odd root of a negative number. We cannot take an even root of a negative number. And just a little side note, here's why. Because if I look at negative 2 cubed, That means negative 2 times negative 2 times negative 2. This gives us a negative 8. So that result is negative. So we would say the cubed root of negative 8 would give us a negative 2. But if we did negative 2 squared, this is negative 2 times negative 2, which is a positive 4. Notice that came out positive. So I cannot take the square root of a negative 4. Later on, and either by the end of this week or into next week, we're going to get into imaginary numbers, and that's where this comes up. So the square root of negative 4 is not a real number. So going back up to this, as long as the root we're taking is odd, we can have a negative number underneath. If we're trying to take an even root, a fourth root, a sixth root of a negative number, right now that is not possible. But we will get to that eventually. So pause the video to continue writing that down. Now I'd like to get all the negatives out, so I don't want to leave any negative values underneath the radical. So what we're going to look at here is negative 2. We're going back to our list of perfect cubes. So right here, I'm just looking at this list, 8 goes into 48. So the way I want to write this is negative 2 times the cubed root. Since the 8 is the perfect cube, I'm going to put the negative with that. So it's negative 8 times 6. Now this v to the 7th, I want to factor this into 2 parts, and one exponent needs to divide by 3. So that's going to be a 6. So I'm going to use v to the 6th times v. So there's my v to the 7th factored. So now I'm going to circle the negative 8, and I'm going to circle v to the 6th. So I still have the negative 2 out in front. The cubed root of negative 8, just as we showed you over here, is going to become a negative 2. Now the cubed root of v to the 6th, simply divide the exponents. So 6 divided by 3 is going to be squared, v squared. And then what I have left underneath the cubed root is 6v. So I'm actually going to get a positive 4 v squared times the cubed root of 6v. Now I like to leave a little space here just in case the v didn't have an exponent. I don't want this index to look like it's the exponent of the v. Always try to write it very close to the radical itself. All right, let's take a look at number 25. Here we have the cubed root of negative 135 x to the 5th y cubed. And I want you guys to pause the video, go back to your list of perfect cubes and see if you can factor the negative 135, and then see if you can also do the variables. But pause the video to do that. All right, if you need more time, just pause again. So how we're going to factor the negative 135. So if I go back to my list of perfect cubes, I would probably want to start with 64, maybe divide the negative 135 by 64, and that doesn't work. But when we divide by 27, it's actually 27 times 5, or in this case, negative 27. Since the 27 is the perfect cube, I'm going to put the negative with that. Negative 27 times 5. How do you think we should factor x to the 5th? I want to get the closest number to 5. That's obviously less than it. That divides by 3. So that's going to be an x cubed times x squared. And then y cubed is perfect because it already has the 3. So I'm going to have a y cubed here. All right, so we're going to circle the negative 27, the x cubed, the y cubed. All of those are going to come out. The cubed root of a negative 27 is a negative 3. Cubed root of x cubed is just x. Cubed root of y cubed is just y. Then we'll leave a little bit of space, the cubed root of 5x squared left over. All right, we'll try one more, number 39. Here we have 6 times the 4th root of 648, x to the 5th, y to the 7th, z squared. Again, pause the video if you wish to try this on your own. I will point out we're trying to take the 4th root of this. All right, so go back to your list of 4th powers and start dividing 648 by these numbers. And hopefully we're finding that it's 81. So we're still going to have the 6 out in front. We'll have the 4th root. We're going to factor 648 into 81 times 8. X to the fifth, just like this x to the fifth up here, is going to become x cubed times x squared. Y to the seventh, like the other problem, is going to become y to the sixth times y. And then z squared is just not large enough to do anything with, so we just leave it. So now we're going to circle the 81. Actually, I was thinking to the third power, so let's go back. We've got to go back and retry these variables. Very easy to think of the incorrect root here. We're so used to doing square roots or cube roots. So let's see. We need this to divide by 4. So x to the fifth, we're actually going to factor into x to the fourth times x. Y to the seventh becomes what? Y to the fourth times y cubed. And again, z squared we're going to leave alone. All right, so now we're going to circle x to the fourth, y to the fourth. So we still have the 6 on the outside. Fourth root of 81 is what? Should be 3. Fourth root of x to the fourth is x. Fourth root of y to the fourth is y. Then we just have the fourth root of 8y cubed, or x rather, y cubed, z squared. Then we'll just multiply the numbers out in front so we get an 18xy. Again, leave a little bit of space, the fourth root of 8xy cubed, z squared. So now that these are all getting mixed together, you could see it's very easy to think and have your be focused on one root, but here we were doing the fourth root. So pay attention to what the index is. So off of this worksheet, I want you guys to do the evens. So the higher roots worksheet, please do the evens only. Tomorrow I'm actually going to go back over from right before Christmas break the quiz that I gave you guys. I definitely want to talk about and revisit some of the problems, especially with multiplying by the conjugates. So please make sure you have previous homeworks with those and your quiz results as well. Like I said, I definitely want to go back over those problems and give you guys more practice with those. All right, so take care. Let me know if you have any questions.